All right, guys, let's continue on our notes about sequences here. So in class on Tuesday, we did this first page here, and then we did examples 3 and 4. So that should be about as far as we've gotten. So let's take a look at number 5 and 6. Okay, let's take a look at number 5 right now. Write a rule for each sequence, then give the next 3 terms. Okay, so what we need to do is we need to basically, so writing the rule is basically just saying, writing out mathematically what the pattern is. So we have to determine what the pattern is. So the patterns in some of our previous ones were, okay, take the previous term, add 9. This one is take the previous term, multiply by 2, and then subtract 5. This one's take the previous term, add 6, divide by 3. Okay, and then the last one there is take the previous 2 terms, multiply them together. So we kind of need to know what pattern is going on here. Okay, so it could be really anything, so you need to take some time to kind of play around with the numbers and how they got there. So I always like to see if it's easy to see what is the difference here, what are we adding or subtracting, and see if that is consistent with the next one. So 4 to 11, we're adding 7, but then if we add 7 to 11, we would get 18, not 32. So that one's out. Let's see what else do we have here. What are some ways we can get to 11? If we multiply by 2 and then add 3, okay? From 4 to 11, we multiply it by 2 and add 3. So if we multiply 11 by 2 and add 3, would we get 32? Well, 11 times 2 is 22, add 3 is 25. So no, that's not enough. What's another way we can get to 11? We can multiply by 3 and subtract 1. So that would be, times 3, then minus 1. 11 times 3 is 33, minus 1 is 32. Well, that's working for these ones. How about for 32? 32 times 3 is 96, minus 1 is 95. Okay, so it looks like this is going to be our pattern. 95 times 3, 27, 28, 285, minus 1 is 284. Okay, so I think we found our pattern here. So basically what we're doing to get these is we're multiplying by, so we're taking the previous number, we're multiplying by 3, and then we're subtracting 1. Okay, so a sub n, whatever number we're looking at finding, we need to take the previous number, and remember a previous number is a sub n minus 1, and we want to multiply that by 3. So we're just going to do 3 times a sub n minus 1, and then we're going to subtract 1 off the n. Okay, this was the rule for what we just found in this pattern. Okay, a sub n equals 3 times a sub n minus 1, and then minus 1. Okay, and remember this a sub n minus 1 is just our way of saying, yeah, we're just looking at the previous term, right? So then we're going to use this to find the next 3 terms. Okay, so we have 284 here. So we want to take 284, we want to multiply by 3, 24, 25, 852 minus 1. So then we have 851. That's the next term. Let's look at if we take 851 times 3, 15, 25, 28, 2,500, 2,000, hang on, why did I write 20? 8 times 3 is 24, 25. 2,553, well, we minus 1 is going to be 2,552. One more here, 2,552 times 3, 6, 15, 16, 7. 7656 minus 1, 7655. Okay, so these are the next 3 terms in that sequence. Okay, on to this one. We need to figure out what the rule is for this one. So what's the pattern? What's the pattern here? So we're going to have to kind of play around. So let's look at, like I said, I always like to find the differences first. So this is a difference of 40. This is a difference of 20. This is a difference of 10. This is a difference of 5. Interesting. Okay, so that is saying something. The difference is going down by a half of the previous distance, but we don't really know a way to talk about that, the difference between the two. How can we go from 100 to 60? So we can minus 40, but if we minus 40 from 60, we would get 20, not 40. So we can't just minus 40. We can divide, let's see, we can divide this number, oops. If we divide this number by 2, we'd have to add 10 to get 60. If we divided 60, oh, here we go. If we divided 60 by 2, we would get 30, add 10 to get 40. If we divided 40 by 2, we would get 20, add 10, 30, 30 divided by 2. Okay, so I think that's it. I think that's what we're doing. So we're taking the previous number, we're dividing by 2, and then we're adding 10 here. Okay, so a sub n is equal to the previous number divided by 2. So a sub n minus 1 divided by 2, and then we're adding 10. Looks like this is the rule for here. Now let's see what this would be for the next 3 terms. So if we take 25, divide it by 2, that's going to give us 12.5 plus 10 is 22.5. Okay, 22.5 is going to be 11.25. Okay, that plus 10 is going to be 21.25. 21.25 divided by 2 is going to be 10.625. That plus 10 is going to be 20.625. Okay, and there is our next 3 terms there. Okay, so we're going to take a look at explicit formulas, and then we're going to do a couple of these ones here. Probably just these odd, 7, 9, 11, 13, and 15 for practice. So definition time here. Explicit formula is a rule in which the nth term is defined as a function of n. Okay, so here, previous terms, unnecessary. I don't know if I spelled that right. I always have trouble with that word. Okay, so basically what this is saying, so in our recursive formulas, what was happening is we went back to the previous term, we took that number, and then we did something with it. But now in our explicit formulas, all we care about is n, whatever n is. So if I want to know what the 15th number is, I don't need to know what the 14th number is first to find it. All I need to know is that it's the 15th number, and n is 15. Okay, so if we wanted to start this off, let's see, find the first 5 terms in the sequence. So we need to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So none of these are dependent on each other. All that we're worried about now is what this subscript is. What number in line are we looking for here? So, but we're looking for the first 5. So first we're going to start with a sub 1. So n is equal to 1. So we'll just substitute 1 in here. 1 minus 3 is negative 2. Negative 2 times 7 is negative 14. That's our first, that's our first term here. And notice, you know, in the recursive formulas, we were always given like the starting point, right? Because our rules always said, well, you have to go back to the last number. Well, you have to have a number to start with so you can go back. But in explicit formulas, you don't have to give your starting number because all you need to know is what n is. And for the first term, n is 1. And so then you use that information to find what the value of that term is. So for our second one here, n is equal to 2, right? Because it's the second number in line. So we'll just substitute 2 in here. 2 minus 3 is negative 1. Negative 1 times 7 is negative 7. On this one, n is equal to 3. So now we're going to put 3 in here. Well, 3 minus 3 is 0. 0 times 7 is also 0. Once we put in, that's 1, 2, 3, 4. 4 minus 1 is 1. Times 7 is 7. 5 minus 3 is 2. 2 times 7 is 14. There's our first 4. This is a infinite series, right? Because we can keep going up forever. N can just keep going up by 1 every time. So we're going to do that dot, 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 and close it there. Okay, so maybe, let's see. I can probably do... Don't know that I'll do 9 and 11. That's fine. I just don't want this video to be too long for you guys. It's already at 10 minutes. Okay, let me just do one more. Let's do number 11 here. Okay, so we're still finding the first 5 numbers of the sequence. Okay, so the first one, the first number, a, is equal to 1 because it's the first number. So we're going to do, put a 1 up here, oops, for n. So 1 minus 1 is 0. Anything to the 0 power is always going to be 1, no matter what the base is. That's the 0 exponent rule. Okay? To find the second number, we need to put in 2 for n. 2 minus 1 is 1. Negative 2 to the first power is negative 2. Easy enough. The third number in line, n equals 3. 3 minus 1 is 2. What is negative 2 squared? Well, that's positive 4. Okay, our fourth number in line, n is equal to 4. 4 minus 1 is 3. Negative 2 raised to the third power, or negative 2 cubed, is negative 8. 1, 2, 3, 4. Last one here, n is going to be equal to 5 because we're looking at the fifth number in line. 5 minus 1 is 4. Negative 2 to the fourth is going to be positive 16. Okay, and then we'll keep that pattern going there. And there's our first 5 terms. Okay, so again, these are just dependent on what number in line, what spot in line are we. That's all that matters. We're not looking back at the previous number. Okay, write a rule for each sequence. Okay, so remember these are going to be related to the spot in line that they are. So this one is going to be related to 1, this one's going to be related to 2, this one's going to be related to 3. So how do we use those numbers 1, 2, and 3 to get to negative 7, negative 9, and negative 11? So notice how we are getting negative. We're getting more negative as it goes on. Okay, so let's look at 2 and negative 9. So let's try to come up with how can we use 2, what can we do to 2 to get negative 9? So we can't just multiply 2 by something because these are all odd numbers. So maybe we have to multiply 2 by something to get and subtract 1 or something. So if we did 2 times 5, 2 times negative 5, negative 2, if we multiply negative 2 times n, which is 2, that gives us negative 4. If we multiply negative 4, negative 4 times 2 is negative 8. and then we could subtract 1. That gives us negative 9. Let's see if it works for negative 11. Negative 4, now we're times 3 minus 1. Well, negative 4 times 3 is negative 12, minus 1 is negative 13. Okay, so that's too far. Let's go back to this 2 idea. Negative 2 times 2 is negative 4, and then we would subtract 5 here to get 9. Let's see what we can do with 3 and 11. Negative 2 times 3 is negative 6 minus 5, negative 11. There we go. Negative 2 times 4 is negative 8 minus 5. Okay, so I think I found our rule here. We have to multiply each of the numbers by negative 2 and then subtract 5. Okay, so remember in these explicit formulas, we're starting with n. So a sub n is going to equal, we said we're multiplying by negative 2, whatever n is, and then we're subtracting 5. And then give the next 3 terms. Okay, so if we keep doing this, this is n equals 1, 2, 3, 4, 5. So the next term, we're going to take 6 times negative 2 is negative 12, minus 5 is negative 17. 7 times negative 2, negative 14, minus 5, negative 19. And 8 times negative 2 is negative 16, minus 5 is negative 21. So there's our next 3 in line. All right, that's it for now. Go ahead and work on these, and you can work on your homework as well.